Okay, so we've started recording. So now what we're going to do is I will share my screen and we will start looking at these questions here. Okay, so what I'll do is, given that we have um, not a lot of time, what I'll do is I'll do the main parts of the question. So there might be some things that I'll skip, okay, just to try to save a bit of time. So please stop me if you have any questions, all right? Because we've only got about half an hour left. I'm going to go through them, but let's take a look. So the first question here says a plane is traveling due north at 400 kilometers an hour. A wind is blowing from the west at 90 kilometers an hour. Determine the resulting velocity of the plane. Okay. And then here it looks like it asks you to see if this is a correct or incorrect answer. Okay, we'll take a look at that later. But in the end, when you're solving problems like this with geometric vectors, it makes sense to just draw it out. Okay. Now, I think the trick here is that it says blowing from the west as opposed to saying blowing toward the west or westward. Okay. So you have to think west is over there. If you're blowing from the west, means you're actually going eastward. So when you're drawing your diagram, it was north, right? Is blowing north at 400 kilometers an hour. Okay. And then it's blowing from the west, so towards the east. And you want to find the resulting velocity. So that means you have to add them together. So you're going to put them tip to tail. Okay. And this one here is 90. Okay. And remember what we said before, when you're adding two vectors tip to tail, the resultant goes from the tail of the first to the tip of the second. Now, because this is, north and this is east, we know that these two things are perpendicular to each other. So you actually have a right angle triangle. All right. So in order to solve for the magnitude of this vector, you can actually just use Pythagoras. You don't even need to, find the angle first. Okay, so here the magnitude, we'll say, of the, resulting velocity is just going to be equal to the square root of 400 squared plus 90 squared. Okay, let's just calculate that real quickly. Okay, so square root of 400 squared plus 90 squared. Okay, looks like that's about 410. In fact, it's exactly 410. Okay, and now, of course, in order to give this vector, you also need a direction. But since this angle here is going towards the north and then towards the east, I can just find this vector, this angle here, to describe the direction. Okay, and here I might as well use 90 and 400. I'll use tangent. Okay, so tan of theta is equal to opposite over adjacent, so 90 over 400. So theta is just going to be inverse tan of 40 over, 90 divided by 400. Okay, and it looks like that's about 12.7. So now we can give our answer. Our resultant velocity is our magnitude, 410 kilometers per hour. And then here we're going north 12.7 degrees eastward. Okay, so here 410 south, 12.7 degrees east. So clearly the direction is incorrect. The magnitude was. So who knows, maybe they didn't go tip to tail. Maybe instead of going from the east, from the west, they went toward the west. So that might have caused the problem. So a lot of things can happen here. Okay, any questions? Okay, let's go to number 2. Yeah, just stop me. I won't see, I can't see the chat. So if you have questions or comments, please just open your mic.
I have a question
Yep.
for how you got the angle. I'm getting 14. I'm getting 1408.
Let's check again here.
Alright.
So here's my angle. The opposite side is 90. The adjacent side is 100. Let's make sure am I in degrees? Yes, I'm in degrees.
Oh,
Might you be in gradients maybe?
yeah, I was.
Yeah. So because gradients and degrees are similar, like one turn of a circle in gradients is 400 degrees, that's why the answers are not that far off, but they're always a little bit off. Okay. So if you get a funny answer, it might just be that you're in gradients. And by the way, if there's anything here you just want me to skip, I'm happy to skip it. So here, determine the equation of the following lines. So here, we're passing through the point 1, 8, -3 and point Q. So you have to imagine you're on this line and you're passing through these points P and Q. Okay. Now, in order to find the parametric equation of this line, first, you need a point. I've got 2 points, so no problem there. And you need a vector parallel to the line. So I can just create the vector PQ, and then that'll be my direction vector. Okay, I forgot what, I'm not sure what, oh no, you probably used M for direction vector, I'm going to guess. Okay, so M here is just going to be the vector from P to Q, and we'll just look on the side, and remember, vector from P to Q, we just subtract. So 6 minus 1 is 5, 8 minus 8 is 0, and then 7 minus -3 is going to be 10. Okay. Now I could keep this vector here as the direction vector, or I can take anything parallel to this vector. So I could multiply it by 1/5, and I could use 1, 0, 2. It really doesn't matter. There's lots of equations we could write. And so now the equation of this line is the vector to one of my points. I'll use, which one looks easier? I'll use Q just because there's no negatives, okay? Plus your parameter times your direction vector. So if I use that as my direction vector, there's my answer, and t can be any real number. Now this is vector form. If we want to write it in parametric form, we just separate out the 3 components. So x would be 6 plus t, y would be 8 plus 0t, so just 8, and then z would be 7 plus 2t. And here t can be any real number. Now the thing about these forms of the equations is that there's different versions. Somebody else might use 5, 0, 10. Somebody else, instead of using point Q, might use point P. There's lots of different correct answers. Okay. If we look at B, what do we have here? We have perpendicular to the line, 3x plus y minus 7, and through the point, so scalar form.
Sorry, but the
Okay.
recording just got
Yep.
fuzzy. Oh,
Oh,
no, it's fixed now.
okay. Yeah, yeah. Sometimes my camera's, is not the newest of cameras, so sometimes it might go off a little bit, but usually it'll come back. Okay, or it'll freeze sometimes. Okay. So remember that if you've got a line that is given in scalar form, like this one is here, the a and the b values represent a normal vector. So earlier we talked about normal vectors. So for this line, the normal vector would be 3, 1. Okay. But what we're looking for is perpendicular vector. So we need to find a vector that's perpendicular to this line. Okay. And an easy way to get a perpendicular vector is to just flip the x and y and change the sign on one of them. Okay, so if this is the vector 3, 1, a perpendicular vector would be negative 1, 3. Now, by the way, notice how I'd made no effort to make my diagram accurate because I'm only using the diagram as a guide. So now, if this becomes my normal vector for my new line, and it passes through the point 2, 5, well, I can just put everything into my scalar equation of a line, ax plus by plus c equals 0, and now replace what I know. A is negative 1. The point that it passes through is 2, 5, so x is 2, b is 3, y is 5, and the only thing I have to do is solve for the c value. So c is going to be equal to, so what do we have? Here we have negative 2 plus 15 is 13. Bring that to the other side, negative 13. And so my final equation is negative x plus 3y minus 13 equals 0. Okay? And now, again, stop me if you have any questions. If we look at this here, well, this is a little tough to draw, and I don't want to try to use what I did before. It doesn't come out so great. But you have to imagine here that if I'm in 3D, okay, and I'm looking at something that's parallel to the XZ plane, okay, and remember, I'm looking for it in vector form. So any basis vectors that work for the XZ plane are going to work for the vector for the plane that I'm looking for. Because if I have, and I'll try to use these here again, if I have two parallel planes, any two vectors, any vector on one plane is also going to be a vector. So let's try to make them parallel. Any vector on one plane I can move, and it'll be a vector on the other plane. Okay. So since I'm on the XZ plane, I might as well use the really easy basis vectors, 1, 0, 0, and this will be 0, 0, 1. Okay, so these are my two direction vectors. And now the other thing I need to get the vector form of the plane is I need a point. But since the plane contains the point has a y-intercept of a 4, well, this point is just going to be 0, 4, 0. Okay, so I have my point, I have my two direction vectors, so my equation can be written as the point 0, 4, 0 plus s times one of the direction vectors, 1, 0, 0, plus t times the other direction vector, 0, 0, 1, and s and t can be any real numbers. Okay, so it's about remembering how we can create vector equations of planes. You need two direction vectors and one point on the plane. Okay, so let's look at the next one here. Any questions on these here, or can I move on? All right. So the next one says describe the intersection of the following three planes without solving, if possible. So here, all we have to do is try to say what type of intersection it's going to have. Okay, but this is where, and I think I have my notes here somewhere, we can check. I'm going to take a look to see. Here we go. Where's my notes? Okay. That for a lot of these, if there's any parallel planes, okay, so here there's two parallel planes, here there's three parallel planes, here there's two that are the same, another one that's parallel, okay, so some of our possible scenarios are going to be scenarios where we have parallel planes, okay, and that's going to help limit what we're going to find. So the first thing you might want to look at is, are any of the normal vectors parallel? So remember your normal vectors, in this case here in 3D, are just going to be the A, B, and C values. So we have 2, -3, -1. The second normal is -1, 2, -5. And then the third normal is 5, -1, -1. Okay, so when you look at these, none of them seem to be parallel. Okay, because here, I would have to multiply this by 5 to go from -1 to 5. Clearly, the others don't work. Here, I'd have to divide that by -1/2. Clearly, the others don't work. So if you look at them, none of them are parallel. So that means there's only 3 possibilities left. Okay, it could be the triangular prism where there's no intersection. It could be the 3 planes intersecting in a line where none of them are parallel to each other, or it could be intersecting in one point. And the difference is that with these two examples, the normals are coplanar, which is what we talked about earlier. The normals are all in the same plane. Whereas with this example, none of the normal vectors are coplanar. So this is where we have to remember how to check whether vectors are coplanar. And you would have seen what's called the scalar triple product is you take the cross product of two of these vectors and then you dot it with the third vector. Okay, and if this is equal to 0, it's either the triangular prism or intersecting in a line. Okay, if it's not equal to 0, then it's intersect in a point. Okay, so if it's not equal to 0, we can say for certain it intersects in a point. If it's equal to 0, it's one of these two scenarios. Okay, so this will be a good opportunity to practice taking our cross product. Okay, so by the way, you could also do n1 dot n2 cross n3. It doesn't matter. Any version will get you to where you have to get to. So let's do n1 cross n2. So remember what my strategy was, is to place them one on top of the other. So 2, -3, -1, -1, 2, -5. And now I'm going to rewrite the x components on the side here, 2, -1. Okay, and let's find the cross product. So remember, hide the x's. So what do we have? We have -3 times -5. So positive 15 minus -2. So plus 2. So that's 17. Okay, then hide the y's. And you have positive 1 minus -10. So 1 minus 1. So 1 minus -10, so 1 plus 10 is 11. Okay, and now let's hide the z's. We have 4 minus 3, which is 1. Okay, so that's this part here. We just took the cross product. And now I'm going to take the dot product with the third vector. And let's see what we get. Well, we get 17 times 5 plus 11 times -1 plus 1 times -1. And I think we can all be certain that this is not going to be equal to 0, but let's test it out anyways. Okay, 17 times 5 minus 11 minus 1, not equal to 0. Okay, so remember what we said. If the triple scalar product is not equal to 0, it means they intersect in one point. Okay,
I have a
now,
question.
yep.
What's that triangle in the X for when you put
Oh,
equal
here,
0?
it's just to show, it's just, so you see here, well, let's go back to my notes here. Where are they? Here. the sort of star would be this one here. Like imagine these planes continue, okay? If you were to look at this from above, it would kind of look like a star, okay? Whereas this one here, the triangle, if you looked at it from above, it would look like a triangle, okay? So that's what those are representing. The triangle is representing this scenario where the three planes sort of form a triangular prism, and the star represents this scenario where they all intersect in a line. Okay, so imagine here, I'm looking at it from above. Where they intersect is actually like a line of intersection. Okay.
All right, so basically, when it equals 0, it's possible that it can have 1 point or 0 points.
No, so this would be 0 points. This would actually be a line, because you have to remember these are not representing that, they're representing planes that are coming out of the sheet. Okay, so let me see if I can maybe show it a little better like this. So imagine these are two planes, and now there's a third plane. You see how the intersection is not just a point, it's a whole line. They intersect on a whole line, all three of them. Okay, and if you were to look from above, it kind of looks like a star. Okay,
Okay.
so it's like looking at it from above, it's like a cross section. Okay, but you imagine when I draw this line here, it's actually representing a plane that's coming out of the sheet, another plane that's coming out of the sheet, and the third plane that's coming out of the sheet. So they actually intersect in one line. Whereas here, it's what we saw earlier. Okay, imagine you have one plane, you have another plane, and you have a third plane, and you see how they intersect only at that one point, all three of them over there. So that would be this scenario when the scalar triple product is not equal to 0. Okay. All right.
Okay.
Let's
Quick
move
question.
on. Yep.
I have a quick question. It says to describe the intersection without solving. Didn't you kind of solve?
Well, no, what I didn't actually find what, when they say solve, means find the actual point. So I didn't actually find the
Oh,
actual
okay.
point.
Okay.
All I did was showed that, yeah. So I see what you're saying. What I did is I did a calculation to help me answer the question. But I don't all I know is that it intersects at a point. I didn't actually find what that point is. That would take some other work.
Makes sense.
Yep. Okay, great. So let's look at I think, are they all calculus now? Okay. How much time? Oh, you know what? We might actually be able to finish this. Okay, so given the curve y equals x root x, at what point on the curve is the tangent parallel to the line 3x minus y plus 6? So the first thing you're going to want to do here, what number is this? Number 4, is, probably rewrite that equation so that it's in slope-intercept form. So you can rewrite that as y equals 3x plus 6. So the slope is equal to 3. Okay. But of course, how do we find the slope of a tangent to a curve? We're going to use the derivative. Okay. So essentially what we need to do is figure out when is the derivative equal to 3. Okay. And that's going to tell us. Now, I notice here it says at what point. I think just to save time, I'm going to find the x values, then you can go and just stick it back into the original equation, okay? It's just going to take time to do that calculation. Now, I'm hoping people look at this and see that I don't actually have to use the product rule, because I can rewrite this function instead of as x root x, write it as x times x to the 1/2, and look at that. I can write it as x to the 3/2. And taking the derivative of this is going to be much easier than using the product rule. Okay, so let's do that. Let's take the derivative now. Now this is very easy. It's just 3 over 2 times x. 3 over 2 minus 1 is 1/2. And you see how much easier it was to determine the derivative like that. Okay. So now let's do A. A says, so we have it here. So when is this equal to 3? So I'm just going to rewrite this as the derivative, 3 half x to the 1/2, and I want to know when that's equal to 3. Okay? But now, this is just going to be x to the 1/2, and let me multiply both sides by 2/3. And look at that. 3's just cancel out. Okay? And here, in order to isolate x, I'm going to perform the opposite operation. I'm just going to square both sides. So x is equal to 4. Okay? So we found the derivative. We determined we were interested when the derivative was equal to 3. I just had to solve that equation. So if you want the point, just put it back in your original equation. Okay? But I'll leave that to you folks just so we can finish this off. So let's look at B. Now, though, they're not talking to us about the tangent, they're talking about the normal. So let's remember what the relationship is. If you have a curve and you find the tangent line, the normal is just perpendicular to that tangent line. So here, if we look at our equation, y equals negative 2x minus 5, the slope here is negative 2. But remember, I'm not interested in the actual slope. I'm interested in its perpendicular slope. Because if that's my normal slope and I want to relate it to the derivative, I have to find the perpendicular slope. And what is the perpendicular slope? Well, it's just the negative reciprocal. So positive 1/2. So this is what I have to work with here. Okay? Because the derivative gives me the tangent, they're talking about the normal, so I have to make sure I take the negative reciprocal in order to solve. And now I could do something very similar. It's not going to be 3/2 x to the 1/2 equals 1/2. Let's multiply again, both sides by 2/3. And now it's the 2's that cancel out. So same thing, I'll square both sides. So I have x is 1/9. Okay, and like before, if I want to find the y value, I just stick it in my equation. Okay, any questions there? All right, so let's take a look at the next question. So it says when a sick student takes an antibiotic capsule, its concentration in their system can be measured using that formula. Okay, when is the concentration at a maximum? Okay, so we should know that when we're looking for maximum and minima, we're going to start by trying to determine when the derivative is equal to 0. So let's start by taking the derivative of this function. Here I am going to have to use the product rule because there's nothing to simplify. Okay, so let's take the derivative of the first function. The derivative of 190t is just 190. Okay, and then that's times the second function, 0.65 to the t. Okay, plus now we're going to take the second function, 190t, and multiply by the derivative of the first function. But again, this is an exponential function. So an exponential function, its derivative is itself. Okay, but then times the natural logarithm of the base. Okay, and we want to determine when that derivative is equal to 0. So hopefully you remember that a really good trick for solving these here is to look for common factors. And I see that they both have a common factor of 190. And more importantly, they both have a common factor of 0.65 to the t. So now let's see what's left over here. Well, I'm just going to have 1. And then here, well, I got rid of the 190. I got rid of the 0.65 to the t. I'm just left with t times ln of 0.5. Okay. I guess let me use the right one. And this is just a constant. This is an exponential function, so it can never be equal to 0. So in order for this to be 0, we need 1 plus t times ln 0.65 to be equal to 0. So t ln 0.65 is equal to -1. So t is -1 over ln 0.65. And since it's an application question, we'll find an approximation. Okay, when you're solving an application question, usually it doesn't make sense to give an answer that looks like that. So let's do -1 divided by ln of 0.65, excuse me, and it looks like it's about 2.32. Okay, but now I need to actually show that it's a maximum at this particular um, value. And so this is where, I definitely don't want to use, so I'll just keep it simple and we'll use the first derivative test. Okay, so I'm going to write 2.32 and I need to test, and I know we're starting at 0. I need to test a value to the left and to the right. So I'll use 1 and I'll use 3. Okay, so now I'm going to put t equals 1 into the derivative. So it's a bit ugly, but we'll take our time here. So we have 190 times 0.65 to the 1 is just 0.65. Okay, and then plus 190 times 1 times 0.65 times ln of 0.65. And what do we get? We get a positive number. So that's a good start, okay? Because we know it's going to be increasing. The function is going to be increasing there. So now let's test 3. And let's do that carefully here. So 190 times 0.65 exponent 3. Okay, and then plus 190 times t equals 3 times 0.65 exponent 3 times ln of 0.65, and we get a negative number. So it means it's going to start decreasing. So that means we have a max concentration at t equals, and this is in hours, so 2.32 hours. Okay. So this tells you that this is the time when you're going to have the most antibiotic in your system. Okay. So I guess it's probably likely when you start feeling better. Okay. Any questions there? All right. So let's take a look at 6 here. So folks, we're not going to be able to get through all of them by 9. I'm happy to keep doing them if you want. I'm happy to stay a little bit more time. Do people want to stick around? Remember, I can't see the chat here. Let me see what's in the chat. That's a transcript. Okay. So, yeah, so let's finish this off. Okay, so remember, I forgot to record the previous part when we did the multiple choice, but this is being recorded. So I will post this later on. Okay, but let's keep going here. So what were we doing here? Oh, the altitude of a triangle is increasing at a rate of blah, blah, blah. What is and while the area is increasing at 2 centimeters squared per minute, at what rate is the base changing when the altitude is 10 and the area is 100 centimeters squared? Oh, I'm surprised. I didn't know you folks did these types of questions this course. Okay, so I'm going to do here and draw myself a diagram. So I got some triangle. the altitude, I'll call it H for height. And then we know that since we're also talking about the area, we're going to need the base. And what we know is that the area of a triangle is 1/2 base times height. Okay. And what we want to know is how quickly the base is changing as the height is increasing at 1 centimeter per minute and the whole area is increasing at, 2 centimeters squared per minute. Okay. Now, the thing that's important to notice here is look at what you're finding the rate of change with respect to. You're finding the rate of change with respect to time. Okay. So obviously to find rate of change, I'm going to use the derivative, but I have to make sure that I'm using the derivative with respect to time. Okay. Now, I know the derivative of the area because they tell me it's increasing at 2 centimeters squared per minute. So it makes sense to take the derivative of the area with respect to time. But of course, that means I have to take the derivative of the other side. Okay, because whatever I do to one side, I have to do to the other side. Okay, and I know already that this is just equal to 2. They gave it to me, centimeters squared per minute. But now, this is where you have to be careful. So the 1/2 is just a constant. That's not a problem. But here, the base is changing with time and the height is changing with time. And these two functions are being multiplied, which means I have to use the product rule. So this is where you have to be careful that you have to use the product rule here. So let's apply the product rule. So the derivative of the first function, so the derivative of the base with respect to time, times the second function, h, plus the first function times the derivative of the second function. Okay? And this is where you see why they gave us maybe some extra information. So let's see what we need here. Well, first of all, this 1/2, let me multiply both sides by 2. So at least I get rid of the fraction. There you go. Well, the derivative of the base with respect to time, that's what I'm looking for, right? I'm just looking for how the base is changing with respect to time. Okay. Then I need the value of the height at the particular moment in time. But they tell us at what rate is the base of the triangle changing when the altitude is 10 centimeters. So I know the height needs to be 10 centimeters. Okay. Plus, well, I know how the height is changing with respect to time. It's just changing at 1 centimeter per minute. But now this is where we have a bit of a problem. We need to know what the base is at this moment in time, but they didn't give us the base. However, they did tell us that at that moment in time, the area is 100. So I'm going to be able to calculate the base because if the area is 100, okay, I don't know the base, but I know the height is equal to 10 at that moment in time. Okay, so here we have 100 equals 1/2 of 10 is 5. So B at that moment in time is just going to be 20. And there you go. And you see now how I have all the information that I need because the derivative of the base with respect to time. So 4 minus 20 is negative 16. Okay. And now let me divide both sides by 10. So the derivative of base with respect to time is negative 1.6. Okay, so that's telling you that the base is, and this is where you have to be careful, it's negative, so it's decreasing at a rate of 1.6 meters per minute. Okay, so here the height is increasing, the area is increasing, but as the height increases, it looks like the base is decreasing. Okay, and so This is a pretty interesting question. This, I would say, is probably a thinking type question because it's got a lot of moving parts to it. Okay. Anybody have any questions on this one?
Yes, sorry.
Yeah.
How do we get to the negative 1.6? I was also writing and I kind of missed that part.
Oh, yeah. So here, what I want to do is I want to isolate. Hold on. Okay. I want to isolate the derivative of the base with respect to time. So the first thing I did is I subtracted the 20 from both sides. So that's how I got the negative 16. And then here, I divided both sides by 10 in order to isolate dB dt. So negative 16 divided by 10 is negative 1.6.
Okay, makes sense.
Make
Thank
sense?
you.
Perfect.
Mhm.
Okay, anybody else on this one? No? Okay. So let's look at this last question. So find the point or points on the curve at which the tangent has a horizontal slope. Okay, well, actually in some ways this is easier. Let's say that's a tougher question than this one here, but it ends off on that. Let me get a new sheet of paper. Okay, so it looks like I guess this is number 7. All right, so let's write down the function. It's y equals 3 minus x squared times e to the x. Okay, and we want to determine when the tangent is horizontal. Okay. And so, of course, what gives us the tangent? The derivative of the function. So step 1 is to take the derivative. So again, product rule again. The derivative of 3 minus x squared is just negative 2x times the second function, e to the x, plus the first function, 3 minus x squared, times the derivative of the second function, derivative of e to the x, is just e to the x. And now we want to determine when this is equal to 0. Okay? And like we did before, we did something very similar, is you look for common factors, and we see that the common factor here is e to the x. So let's see what we're left with here. Here we're left with the negative 2x. Here we're left with 3 minus x squared. And now we can solve this problem. Okay? E to the x is never equal to 0, so that's not going to give us a solution. So we just have to determine when this expression is equal to 0. So when negative x squared minus 2x plus 3 is equal to 0. Now, of course, factoring is a lot easier when I have a positive leading coefficient. So let me divide both sides by negative 1, just so that I'm left with x squared plus 2x minus 3 equals 0. And now this is much easier to factor. Okay, so two numbers that multiply to negative 3 and add up to positive 2. So that looks like it's going to be x plus 3, x minus 1. Okay, negative 3, negative 1 plus 3 is 2. And so it looks like our answers are x equals negative 3 and x equals 1. Okay. And like the question before, it says find the points on the curve. So in order to find the points, you would just take these x values, put it back into the original equation to find the y values. But since that's just calculating stuff, I'll leave that for you folks to do. Okay, any questions on this one here? Okay, so what I'll do is I'll stop the recording. Where's that?